Alright, y'all, this stuff today is pretty easy. Basically, if you know how to graph a line, then you should be able to do this today. We are going to be starting the systems unit, and there's going to be a few different ways that we talk about to solve systems. We're going to talk about graphing today, we're going to talk about substitution next time, and we're going to talk about elimination. Okay, and each way to solve a system you're going to use for different circumstances. So what we're going to see today is maybe if both the equations are given to you in y equals, it might be easier to use the graphing method because you're also, if it is graphing, you can even do those in your calculator. I'm actually going to save, the very last slide of these notes is talking about how to do it in the calculator, but I'd rather be here for that. So I'll walk y'all through that on Tuesday of next week. Okay, it is first important, so this whole unit is going to be over systems, so it's important that you actually know what a system is. So this says a system of linear equations consists of two or more linear equations with the same variable. And notice that it does say two or more, but the systems that we deal with are going to have two equations that have the same variable. Okay, that just means you're going to have an equation with a y and an x and another equation with a y and an x. Or you may have just a y or just an x, okay, but ultimately it's really just two equations that make up a system. Okay, the most important part of today, and really this whole unit, is when you're asked to find a solution to the system, you need to know what that means. Okay, and ultimately, even if you're not using the graphing method, the solution of the system is an ordered pair that satisfies each equation, which means you are looking for an intersection. Okay, so I want y'all to write that down. You are looking for an intersection. So when it says an ordered pair that satisfies each equation in the system, if you find where those two lines intersect, then that tells you that that point would satisfy both equations. It would work if you plugged the x and the y in, it would work for both equations. So if you look at this example, okay, first looking at that red line, you have y equals negative x minus 4. So you see it started at negative 4, and then your slope's negative 1. So that's where this red line came from. And then your blue line, you have y equals x plus 2, so it started at 2, and it went up 1 over 1. Okay, you always want to graph these lines until you see where they cross. And what you're going to see with these graphing systems, I don't need you to plot 15 points on each line. I need you to plot enough points to where you see where they intersect. Okay, so you can see that these two lines intersect. Oops, that's purple. These two lines intersect right here at that point. So the solution to this system, let's see what the ordered pair of that is. 1, 2, 3. So negative 3, negative 1. So if you were asked to solve the system, your answer would be negative 3, negative 1. Okay, that's basically the notes. Okay, we're just going to do some examples. Alright, so we have y equals negative 2x plus 1 and y equals x minus 5. And this is asking me to solve the system by graphing. Okay, which is the only way y'all know to solve the system right now. So this should be easy. Alright, so starting with that first equation, I'm going to start at 1. And then my slope's negative 2. So I'm going to go down 2 over 1. With that first line, you're going to need, 4 or 5 points because you don't know where these lines are going to intersect yet. Okay, that line, I'm going to go ahead and draw that in. Okay, now this second line, I'm going to start at negative 5, and my slope's 1. So I'm going to go up 1 over 1, up 1 over 1. As soon as you see where those two lines intersect, I am good with you just stopping graphing that line. You don't need to graph it all the way through that grid. Just draw that line in. And now you can see where these two lines intersect. So the solution to this system is going to be whatever that ordered pair is, which it looks like it is at 2, negative 3. The good news about all of these systems is if you wanted to check these, you could, because that point needs to work in each one of those equations. So I could take 2 and I could plug that in for my x's, and I could take -3 and plug that in for my y's, and these equations have to be true. So if you look at that first equation, okay, -2 times 2 is -4, -4 plus 1 is -3, so that works. Then the second one, 2 minus 5 is -3, so that works. You are trying to figure out an x and a y value that will work for both equations. All right, so let's look at this one. Now this one, you're going to see later on in this unit that if you're given a problem like this, you're probably not going to solve it by graphing because it's just not going to be the easiest method with the way this is set up because these aren't both in y equals. But that's how we're going to solve this today. So we need to solve for y in both of these. So I'm going to subtract 3x. So for that first equation, we have y equals -3x plus 9. I'm going to go ahead and graph that. Now this is kind of a funny graph because notice they're going by 2's. So if I want to start at 9, I'm actually starting between 2 lines. Now if I want to go down 3 over 1, if I'm at 9 and I go down 3, I'm going to be at 6. Okay, and then over 1, notice it's the same deal on our x-axis. They're going by 2's. So if I go down 3 to 6 and over 1, I'm actually in between the 0 and the 2. Okay, then I'm going to go down 3 more. Now if I'm at 6 and I go down 3, I'm going to be at 3. And I go over 1, and then down 3, over 1. And I'm just going to assume that those 4 points are going to be enough for me right now. I'm going to draw that line in. Now I'm going to solve this other equation for y. So we're going to subtract x. That gets me -y equals -x plus 1. But I can't graph that because I haven't solved for y yet. So I have to divide everything by a -1. So that gets me y equals negative divided by a negative is positive, so x. And then 1 divided by -1 is -1. So I'm going to go over to my graph. I'm going to start at -1, which again, these are going by 2, so be careful there. And then I'm going to go up 1 over 1. So it's like half a block for each one. So up 1 over 1, up 1 over 1, up 1 over 1. Okay, now here's the deal here. Notice these do not cross at a pretty point. Okay, so I cannot look at this right now and know for sure where those 2 lines cross. We are just going to estimate right now what this is, and then I told y'all next time I will show y'all how to do this in your calculator. Okay, but again, something that's set up like this, you're probably going to use a different method of solving this once you learn all the methods. But for today, we're just going to kind of guess where this is. So it looks like it's probably about, you know what, we'll even be nice with this. We'll just say this is at 3, we'll say it's at 3.1. It's not exactly 3.1. It ends up being a decimal, but we're just going to say it's 3.1. Okay, but again, if you were given something like that, you could do it in your calculator. The ones we give you on the homework are going to be really pretty, so you won't have to worry about that. Okay, I'm actually going to skip these. If you need more examples, just go back and watch the ones we've already done. Okay, and I'm going to skip these also. And we're going to jump here. All right, so these say, solve the following system by graphing. Okay, we can't graph these yet because they're not in y equals. So I'm going to add 2x. So my first equation, I'm going to have y equals 2x plus 1. In my second equation, I'm also going to add 2x. So I have y equals 2x minus 3. right? And I'm going to graph both of these. So y equals 2x plus 1, I'm going to start at 1. We have a normal graph here. Then I'm going to go up 2 over 1, down 2 over 1. Just get 4 or 5 points on that first line. Remember, you should never graph a line wrong because you can check them in your calculator. You just type in your y equals and hit graph. Right, and then y equals 2x minus 3, I'm going to start at negative 3, and then I'm going to go up 2 over 1. Okay, so we have a problem here. Because the solution to a system, remember that a solution is an intersection. Okay, assuming you graph these lines correctly, we are looking for an intersection. Do you see an intersection? No, these are parallel lines. Okay, parallel lines never intersect. And if they never intersect, what does that mean about the solution? That means there is no solution. So if you were given this question and it asked for the solution, you can't just leave it empty or just leave it with the graphs. You have to actually write no solution. Okay, I'm going to tell you again why that is. Remember, a solution is an intersection. If they do not intersect, there is no solution. Okay, now looking back at those two equations we just had, look at what you notice about these two lines. They have the same slope. What did the same slope mean? Same slope meant parallel lines. Parallel lines never cross, so therefore there's no solution. So that might even be something that you recognize from the very beginning and not have to graph them. But most of the time we're going to need to see it on the graph. Okay, we do need to do this one because it's a little bit different. So this first equation, I'm going to subtract x. So I have 3y equals negative x minus 3. I'm going to divide everything by 3. So we have y equals negative x over 3. I'm going to go ahead and write that as negative 1/3 x. Make more sense. And then negative 3 divided by 3 is negative 1. And we'll graph that here in a second. The second equation, I'm going to subtract 3x. So I have 9y equals negative 3x minus 9. Divide everything by 9. So I have y equals negative 1/3, because negative 3 divided by 9 is negative 1/3, x, and then negative 9 divided by 9 is negative 1. So I want you to look at these two equations right now and see if you notice anything. Okay, these two equations are actually exactly the same. So we're going to see what happens there. So I'm going to go ahead and graph this. I'm going to start at negative 1. And my slope's negative 1/3. So I'm going to go down 1 over 3 or up 1 over 3. So there's my first line. You don't really need to graph the second one because it's exactly the same, but I'm just going to show you. It starts at negative 1, goes down 1 over 3, and you have the exact same line. So if you think about this, you have a line right on top of another line. How many times do those lines intersect? Well, they intersect like 1,000,000 times. Actually, there's not even a number for it. So these two lines intersect an infinite amount of times. So, but remember, we're looking for intersections. Those intersections are called solutions. So if it intersects an infinite amount of times, that means we have an infinite amount of solutions. So we have infinitely many solutions. So if you want to write this down, actually I think it might be on the next slide. Actually, we're going to skip the next slide. Okay, but it talks about it here on this slide. Okay, it says number of solutions of a linear system. Okay, we saw on the first couple that we did, they intersected. We just had one solution. Okay, we had one point, one ordered pair where they intersected. Okay, so they had different slopes. You have no solutions when you have parallel lines. Remember, a solution is an intersection. I'm just going to keep saying that. A solution is an intersection. If they do not intersect, then there is no solution. Okay, then you'll have infinitely many solutions. I know you only see one line here, but this is really two lines. Remember, a system is two equations. These are two lines on top of each other, which means they intersect an infinite amount of times, so infinitely many solutions. Okay, this last slide, I told you I'm going to save this for next time. If you get really, adventurous and want to go through these steps and try this in the calculator, you can. But you are just going to be expected to do those problems on your homework. All the problems on your homework are already in y equals. That's because we only really want you using this method if they are in y equals. Okay, so you'll do your homework and then we'll go over this calculator stuff next time.